Hi, welcome to this very brief demonstration on how to use our recentering tools. Um, at the moment, recentering is under active development, and this video will serve as a very brief mini tutorial for those of you that want to test it. Testing is not for the faint at heart. The user interface is far from optimal, but the technology is really interesting, and I hope you will be inspired to give us feedback on how you want to see this being pushed further. As you can see, I have the B3 Mini interface open, and I have defined my my puck and my pucks and how they are loaded in the doer. What I'm going to do is I'm going to make a new sample information list. It's going to be called RC test 7 create, and that has been created. And what I'm going to do here is I'm going to do a refresh here. I'm going to choose my SIL and I'm going to set up a very quick screening run. We are going to screen 2 crystals, 7, screen A, and we are, there should be screen here, screen A, and this is fine. Make sure that the recenter button is clicked here, and make sure that your SIL is the right one that you have just defined. Yes, we have done that properly. And then select the pins that you want to work on. That's pin 1 from A, and then I'm going to do the same thing for B, and I'm going to add that to the queue as well. I'm going to start the queue. What's going to happen is that the first pin is going to be mounted, and that is now on the way. The gripper at the moment is at 20 degrees and rapidly cooling. It is being dunked in liquid nitrogen. I can show you that here by using the pan zoom, tilt PZT and camera PZT. Should come up. I'm running this remotely, so it might take some time. Yeah, you can see it's barely visible, but the gripper is actually inside inside the doer, somewhere here. I'm going to close this because displaying a video like this eats bandwidth. So it's when you run this remotely, do not look at this unless you really have to. Okay, so that's out of the way. The gripper temperature is now -150, and it's now going into the pre-mount state. Gripper is at -170 almost, and the robot has just mounted our crystal. Let me go to low magnification, and I'm going to center this sample, and right there, turn it by 90 degrees and center it up. And this always takes 2 clicks. This sample has been beaten up pretty badly. As you can see, I've been using this sample for testing today. It doesn't look as pretty as your samples will be, but it will do for now. And look, there you can see it. It's always worthwhile to go to log magnification to see if you can see something interesting, because in high magnification things might not always be as clear immediately as you want it to be. Okay, this looks good. I think I need to go up a bit here. I would use a raster scan on this one, personally, if I do not know where it is. It's very easy to set up. We have tutorials for that as well. Yeah. Let's move it over a bit. And this should do the trick, I think. I'm going to click resume now, and what's going to happen is that we're going to take, the system is going to take an image at 0 and an image at 90, and then we are going to use that information for auto-indexing. In order to keep the video as short as possible, I want to upload this into YouTube. I'm not going to look at the strategy. I'm just going to briefly show you where it is. So here, this is an image here of angle 0. It looks beautiful. There's probably a good starting angle. and here is 90 degrees away. It looks pretty decent as well. So if we're happy with this position, we say resume, and what's going to happen is that we are now going to low magnification, and we're going to save the motor positions where we are actually how we have centered, and we're going to save images at 0 and at 90 to make sure that we know exactly how we have centered the sample. We also do this in high magnification, as you can see here, and as soon as this information is stored, we're going to unmount the crystal and then move on. So it is moving the collimator out. I'm going to change the magnification to low mag to anticipate centering the next sample. It's cooling the gripper. As you can see, the status here is cool gripper. As you can see the temperature here. The ring is still up. We have 500 milliamps running. This is pretty good. And here you can also see what your phi is and actually what the beamline is online, and we're not collecting because the collector is not running. And at the moment, state is mount. That basically means that the robot is busy. That was the robot coming in, and here you see a very nice Martigen tennis racket. And again, because I have looked at the samples before, I know exactly where the crystals are. In doubt, run raster scan or raster yourself manually, whatever you fancy. But this looks pretty decent. Let me go to high magnification just to make sure that things are okay. Let's see, this is fine. And actually this is the crystal right here. I'm just going to move it right there. And this looks good. Okay, I'm going to say resume. It's going to collect 0 and at 90. And when that is done, our screening run is done, basically. And then we're going to start a collect run. So let's see how these images look. I predict no ice and beautiful diffraction. Look at that. And 90 degrees away. There we go, it's moving the gonio, as you can see. And that is the other image. It looks very nice. Pausing for user action. What I'm going to do is I'm going to say resume. So again, it's going to low magnification. It is writing down exactly, storing exactly how we have centered, where we have centered. Motor positions alone are not enough, and that's why we need to save the images of the crystal on the gonio so that we can use those as a reference to recenter things back. And there we go. So it's done it in high magnification at 0 and at 90, and then when it's done, it will unmount the crystal. Okay, let's go to low mag so that we can see maybe a bit better what's going on. It's cooling the gripper again, as you can see here. State is cool gripper. TQ control is fetch. It means that it's fetching the sample, I presume. And now it should tell us something like, yeah, task queue control idle. Task queue, no more task exiting. There we go. So now let's go back to task queue and let's make a collection run. And for crystal A1, it's important to make sure that we have the right sill, that we say that we are doing a run so that we can define exactly how we want to collect. Let's do 10 degrees for 1 second per shot. Normally you'd actually go to web eyes here. So for instance, here you go to pin A1 and you would see that you would have to start at 254, and that for minimum 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 phi range would span to 344 in order to get complete data. This is of course 90 degrees, and you can get away with delta phi too. Typically, the only thing I use is start phi, and then I take into consideration the delta phi, but typically I just use 1 or whatever one thinks is optimal. So we're not going to do that now because we just want to start quickly. What I will do is I will say, okay, let's go to 254 and let's only collect 10 degrees. So that should look like that. The distance is fine, the delta phi is fine, the directory is correct, and this is a run, and this is for pin LISO 1. It's important to remember that. The best thing is to keep notes. In the future, we will be developing a data collection interface for which you do not really have to be so awake anymore in order to run this properly. But for now, this is a useful shortcut. So we're going to add this to the queue, make sure that it's a run. Yes, it is a run, and we do say use recenter, and this is the range that we want to use. Add to queue, please. Great, it showed up. Let's double click on this just to make sure that it looks good. And as you can see, yes, it does look good to a certain extent. This here doesn't look really good, but I'm not really bothered about that. Let's just see what happens. To 64. Let's see if we can modify this here. Dismiss. Double click again. Okay, it doesn't stick. I hope it is. I hope it's okay internally in the database. In principle, we can also collect on the other one, but that will just take time. So what I'm going to do is I'm just going to say start queue, and let's see what happens. So what's going on right now is, again, the gripper is cooling, and once the gripper is cooled, the crystal is going to be mounted, and it's going to be auto-centered, and when it's auto-centered, it will be we will start to collect on this. So this is right after mounting. Subsequently, we have to set the gonio X, Y, and Z back where they were, according to how we centered things the last time. But as I told you before, that often is not enough to to get to the right position. And that's why we have to compare it to the reference images. And what we do is we compute correlation coefficients to the known images and then see what happens. So in this case, in this orientation, the correlation coefficient is 90%, as you can see right here. So it is doing now the fast phase translation search to find out exactly what the optimal shifts are, and it's going to shift it basically up a bit or down depending on your reference frame. And it went from a correlation coefficient of 90% to a correlation coefficient of 99%, which is really nice. And it decides that this is a good thing, and it's shifting that sample. And it's going back to the to phi 0. You can see here what phi is. And at phi 0, it sees that there's a correlation coefficient of 98, says there's nothing to do, so it goes back to 90. And it also says there's nothing to do, so it goes back to 0. This is not done extremely cleverly, but for the moment we are aiming for something that works rather than something that is clever. We will improve things later by making things clever. So now it's going to save some files so that we know exactly how we have centered the sample, so that we can compare it later. And it is going to switch now to high magnification. and then we center things in high magnification just to make sure that everything's okay. We start off with a correlation coefficient of, let's see what happens, 98. That's nice. It says it's centered. There's nothing that we need to do right now. And the other one is 94, so it probably will fiddle with it just a little bit in order to make sure that it looks better. It's picking peaks right now of the Fourier transform. That is at the moment one of the most time-consuming steps. And the reason why it's time-consuming is because I haven't done it in a sensible manner, as you can see, but it's not too bad. So by just a tiny shift of 9 by 6 pixels, 9 to the right and 6 up, we go from a correlation coefficient of 90 something to 99%, which is really great. And shifting it a little bit differently, you get to go to correlation coefficient of 98%. So now we decide to, now we know where to shift, and that's what it's doing. And it goes back to the other angle, just to make sure that everything's okay. Or actually not to make sure that everything's okay, it's just because it's not smart enough yet. It does see that it's correlation coefficient of 99%, something like that. 98% doesn't do anything. And same thing here, and we'll just iterate between this. This doesn't take a whole lot of time. And yes, we know it is centered. As I told you, the system is not yet very smart. So now it's done writing out some images, and when that is done, we should see a data collection happening. Let's see. Good. And it is starting to collect data, as you can see right here. It starts right here at this particular angle, and it has collected a single image and is now unmounting. The reason why this is a single image is because of a bug that I have been facing all night, and I sincerely hope that John is able to sort this out. Fuck.